Hello everyone. So welcome to another session of basic electrical engineering. We have discussed about different theorems like superposition theorem, maximum power transfer theorem, Thevenin's theorem, Norton's theorem, etc. In today's session, we are going to discuss what is called reciprocity theorem. Okay, let's get into the details. So what is reciprocity theorem? Reciprocity theorem states that in a linear bilateral single source network, if the positions of the excitation and the response are interchanged, their ratio remains the same. What do you mean by excitation? Excitation means an input voltage source, or it may be an input current source. Okay, that excites the network. Anything that excites the network, like a voltage source or a current source, is an excitation. Okay, and response means what? The corresponding output. Okay, so theorem states that you can interchange the positions of the excitation and the response. Their ratio will remain the same. The ratio of response to excitation will remain the same, even if you interchange the position of the source and the output. Okay, that is, if an EMF EM in branch M produces a current IK in a branch K, then the same EMF EK in branch K produces the same current IM in branch M. So it will be clear when you do one of the problems. Okay, let's go and get in the problems. Check if reciprocity theorem holds good for the circuit shown below. Check if reciprocity theorem holds good for the circuit shown below. So we are given a circuit here. You tell me what's the excitation here? It is nothing but the 20 volts voltage source. And what is the response here? Response is the current I, which we need to find. Okay, so we need to calculate what is current I. Right? So how can you find the current I? Many methods. You can go for mesh method, or you can go for series parallel reduction. Okay, there's only one source. So it is easy to apply the series parallel reduction of impedances. Okay, so you see, if you assume a current is flowing through this, at the end of 2 ohm, what happens? One branch will flow through this, one will flow through this. Again, as we arriving at this point, what happens? One will flow through this 3 ohm and one will flow through 2 ohm. Means what? 3 and 2 are in parallel. That combination is in series with 2 ohm. That combination is in parallel with 3 ohm, and that combination is in series with 2 ohm. Okay, so let me write it here. R equivalent will be nothing but R equivalent will be what? 2 parallel 3, okay, plus 2, and that will be again in parallel with 3. That will be series 2. Okay, so that means 6 by 5 plus 2. This is parallel 3, right? Parallel 3, the whole combination plus 2. Okay, so if you do this thing, you will get your R equivalent as 3.5483 ohms. Okay, this will be the R equivalent as seen from points, say, X and Y. Okay, that will be the equivalent resistance seen with respect to terminals X and Y. Okay, it will be 3.5483 ohms. Now, how will you find the current I? How can you find current I? So how can you find the current delivered by 20 volt? 20 divided by 3.548. Okay, so I can write this current I as 20 divided by 3.548. Let me write this as I20. Huh? That means current delivered by the 20 volt source, I20 volt, will be equal to this thing. And how much is that? 5.6365. 5.6365. So that is the current at this point. Okay. Now we need to find this current I. What happens? You can apply the current division law. Main current into a resistance of the other branch divided by sum of parallel branch resistances. Okay. So what will be eventually current I? I can write current I as 5.6365, 5.6365 into resistance of the other branch. Resistance of the other branch means what? 3 ohm. Okay, we want to find current to 2 ohm. So resistance of the other branch means 3 ohm. 3 divided by sum of parallel branch resistances. What are the parallel branch resistances? 2 plus this thing. The 3 parallel 2. That means 16 by 5. Okay, so this will be the current. Okay, this will be the current at 2 ohm. Right. Now, how much is that? If you do this calculation, you will get 2.727 ampere. Okay, so that's the current at point B. Now, what is the current I here? Main current. So this is the main current 2.7273 into resistance to the other branch. That means 3 divided by 2 plus 3, 5. So you will get your current I as 1.6364 amperes. Okay, so here our 20 volt was the excitation and the response I was 1.6364 amperes. Okay, now what does the theorem state? Theorem states that you can interchange the positions of the source and the response. Okay, so now we will interchange the source and the response positions. Okay, so keep in mind previously 20 volt response source was here. This was the response position. Now we have interchanged the source and the resistance. Now we need to again calculate what is current I dash. Okay, for which we need to find what is the equivalent resistance R equivalent. Okay, again, how will you find R equivalent? R equivalent will be what? So 2 parallel 3, series 2, the total combination will be parallel with 3, the whole combination will be in series with 2. So I can write like this: 2 parallel 3, okay, plus 2, whole combination parallel 3 plus 2. Okay, so 2 parallel 3 means 6 by 5 plus 2, okay, parallel 3 plus 2. So if you do this calculation, you should get again 3.5483 ohms. Okay, what did we get previously? Again, same value, 3.5483 ohms. Okay, so here also we are getting 3.5483. Now, how can you find this current I dash? How will you find current I dash? For that, you need to find what's the current at point X and Y. Okay, so how can you find current I 20 volt, 20 divided by 3.548. Okay, 20 divided by 3.548. So how much is that? That will be 5.6363 ampere. Okay, that will be the current at point, say, A. Okay, now how can you find this current I dash? I dash will be nothing but, or let me mark here at point A and B. So what will be my current I? How can I find that? So the current through 2 ohm. Okay, again you can apply current division rule. So you will get current I dash as 5.6363 into what? Into 3 divided by, okay, because we want to find current through 2 ohm. So 5.6363 is the current at this point, point A, right? So main current into resistance in the other branch, that means 3 ohm divided by sum of parallel resistance, 3 plus 16 by 5. Okay, and that turns out to be around 2.7272 amperes. So that will be the current at point B. Now, how will you find current I dash? IB, I will write, IB. So what will be current I dash? Current I dash will be, again, main current 2.7272 into, we want to find current through 2 ohm. So resistance to the other branch, that means 3 divided by sum of parallel resistances. You will get this as equal to 1.6363 amp. Okay, what was the previous value? Again, same thing, 1.6364 amp. Okay, so that means you can interchange the position of the response and excitation. There will be no change. The ratio will still remain 1 and the same. Fine. Let us try another problem. Yeah, this question. Find the voltage V in the network given below. Verify reciprocity theorem by interchanging the current source and the resulting voltage. Okay, so what is the source here? It is 10 angle 0, source of the excitation. What's the response? Response is the voltage across J6 ohm. Okay, so to find voltage across J6 ohm, you need to find current through J6 ohm. How can you find the current? This is a current source. There are only 2 parallel branches, so we can apply current division rule. Okay, so what will you get? Current through 6 ohm, I J6 ohm will be what? Main current into resistance of the other branch. That means 3 minus J4 divided by sum of resistances. That means 8 plus J2. Okay, you can find what's the current. So the current should be around 6.0633 angle minus 67.16 ampere. 6.0633 angle minus 67.16 ampere. Now, what's the voltage of this thing? That into J6. So you will get 36.3798 angle 22.84 ohms. Okay, so that will be the voltage across J6 ohm. Now what we need to do, we need to interchange the position of the response and the source. That means instead of these, say A and B, we have 10 and 0 here, and here we need to measure at point X and Y, we need to measure what is the voltage. Okay, like shown here. Right? Now how can you find this voltage? To find this voltage, you need to find the current across this branch. So how can you find the current to this branch? Again, you can go for your current division rule. Okay, so what is the current to this branch? Main current 10 angle 0 into how can you find that? Or you can convert it to voltage source and also find. Okay, anyhow, you can do it anyway. Right? So eventually what you get? Current through. So we see with respect to points X and Y, J6 and these 5 ohm, 3 ohm and minus J4 are in parallel. So we need to find current through this thing, through the 3 plus 3 minus J4. So main current 10 angle 0 into resistance to the other branch. That means J6 divided by sum of the parallel branch resistances. So you get 8 plus J2. So that current will be around 7.276 ampere. Okay, 7.276 ampere. Right? Now, how will you find the voltage across 3 minus J4? Come into resistance. So 7.276 times this thing into this. Okay, so this much will be the voltage. So you see, here also you are getting a voltage of 36.38 angle 22.82. Here also you are getting 36.38 angle 22.82. So that means you can interchange the positions of the source and the excitation. So the source and the response, or excitation and the response, in a single source linear bilateral acting network. That is what reciprocity theorem states. Okay, so we'll stop here. Thank you.